Okay everybody, welcome to the next video on linuxhint.com YouTube channel. In today's video we're going to talk about 11 important networking questions. So these questions are important and they are general basic questions. Okay, so if you don't know these questions, you cannot have a very strong networking. Okay, so the foundation has to be strong in order to have a strong building, and these are the questions, these are the foundational or fundamental questions on which you can say the stack of the networking it builds up. Okay, so these 11 questions we're going to discuss, and without a further ado, let's start. So the question number 1 is, what is a network? So the idea is that a computer network or a network is a connection or a network between two or more nodes using physical media links, and it could be like the links could be like cable or wireless in order to exchange data over pre-configured services and protocols. Okay, so a network is a collective result of, you can say, different fields, for example, computer science, telecommunication, information technology, computer engineering, electrical engineering, and a lot of other fields. So technology involving their theoretical as well as practical aspects into action. Okay, so the most widely used computer network of today is World Wide Web, which is known as WWW. Okay, next question is, what is DNS? So DNS stands for domain naming system, okay, or domain name system, you can say. It is a naming convention or a naming system for all the resources over internet, which includes physical nodes and other applications. So domain name system, it is a way to locate to a resource easily over a network and serves to be an essential component necessary for the working of internet. Okay, so if you think about it, like, it is very easy to remember google.com, but if you know the address of the Google, the address would be like, I don't know, maybe in numbers, 128.1.1.2.219.113, something like that, right? So let me just write it down here. So down here, which one is easy to remember, google.com or this one, 123.125.897.112? So let's say this is just an imaginary IPv address. So which one is better? So it turns out that humans are very good at remembering names rather than numbers. So the domain naming system is sort of like this. So you don't have to type in these numbers, the exact or specific IP address. Rather, what you have to do is that you have to type in a name, and then using domain name system, your computer would connect to the web and it would convert the name into the IP address, and then basically it would allow you to access the website. So that is how simple it is. So it is always easy to remember names rather than the IP address, as I have mentioned. And the idea is that the IP address the condition of it would get more worse if you talk about IPv6. Okay, so IPv6 and IPv4, they are nothing but just versions of internet protocol or IP. And IPv4 stands for version 4 and IPv6 stands for version 6. Okay, so the domain name system functions to assign domain names by mapping corresponding IP addresses, and it basically works in a hierarchical and distributed fashion. Okay, it doesn't like work in a scattered way, rather it works in a pretty structured and functional way. Okay, so that was all about DNS. Okay, so now let's move on to the next question, which is question number 3. What is HTTPS and what port does it use? So the idea is that HTTPS and HTTP, there is a difference between both of them. Okay, HTTPS is a secure HTTP, and obviously HTTP isn't secure. Okay, so HTTPS is used for secure communication over a computer network, and HTTPS provides authentication of websites that prevents unwanted attacks like phishing or Trojan attacks, things like that, if you're familiar with them. So in bidirectional communication, HTTPS, this is a protocol that encrypts the communication so that the tampering of the data gets avoided. Okay, with the help of an SSL certificate, which is offered by different companies and different domain companies, which actually, they sell you the space for website or data storage, you can say. So with the help of that SSL certificate, it verifies if the requested server connection is a valid connection or not. Okay, so if you talk about the port, then HTTP uses TCP, okay, and it uses the port 443, while if you talk about HTTP, it also uses TCP and it uses the port 80. Okay, so if you talk about TCP stands for Transmission Control Protocol. And if you talk about UDP, it stands for User Datagram Protocol, or you can also say it Universal Datagram Protocol. So once, in case of TCP, I'm saying once the connection, let me just write it down here for you so that it is easy for you, right? So let me just write here, let me just make it smaller a little bit. So TCP, it basically stands for transmission protocol. Okay, let me just write it here quickly. Transmission control protocol. And if we talk about UDP, it stands for basically user datagram or universal datagram. Okay, universal datagram protocol. Okay, and in TCP, what happens is that basically if once the connection is set up, data can be sent bidirectional, and that is basically TCP is a connection oriented protocol, you can say. Okay, so here we can say connection oriented protocol, while in case of UDP, it is connectionless. Okay, it is a simple protocol, and using UDP, if you're gonna use it, they basically send messages using packets. Okay, so here you can say this is a connectionless protocol. All right, so if you talk about TCP, the speed of TCP, if we talk about specifically, then obviously it is slower than UDP, and the speed of UDP is faster if we compare it with if we compare it with UDP. Okay, so yeah, we can write here slow speed, just write here slow speed, and obviously just remember that UDP has a faster speed. Okay, so the next thing is that TCP is used for the application where time is not critical part of data transmission, which means that it would basically transfer the data completely and entirely, and obviously it doesn't care about time. Okay, while in the case of UDP, it basically cares about time. Okay, and it is suitable for the applications which require fast transmission of data, and time is crucial. Okay, and if you talk about the other thing, obviously TCP is a heavyweight connection and UDP is a lightweight connection. Okay, or it has a lightweight transport layer, and TCP, it basically tracks the data sent to ensure no data loss. Okay, while UDP does not ensure whether receiver receives the packets or not. If packets, if they miss, then they are just lost, and you don't know if they are lost until and unless on the other end receiver lets you know. Okay, so TCP ensures packet delivery or the data delivery, while UDP doesn't ensure that. So these were the general differences and general things and general comparison, you can say, between TCP and UDP. Hope you have learned it. So now let's move. Okay, so now let's move on to the next question, which is question number 5, which says, what is a firewall? So firewall is a network security system that is used to protect computer networks from unauthorized access. So firewall, it helps you prevent malicious access from outside to the computer network, and this basically, it can also be built to grant limited access to outside users. So for example, if you're like using your computer and somehow you get this message that do you want this specific application to access your computer, how that message pops up, it is because of your firewall. Okay, so the firewall, it consists of a hardware device, software program, or a combined configuration of both. So all the messages that are route through the firewall are examined by specific security criteria, and the message which meet the criteria are successfully traversed through the network, or else those messages are blocked. Okay, so if you talk about firewall, it can be installed just like any other computer software, and later it can be customized as per your need, and you can have some control over the access and security features of your computer. So let's talk about ipconfig first. So it stands for Internet Protocol Configuration, and this command is used on Windows specifically to view and configure the network interface, while on Linux you use ifconfig or ifconfig, you can say. Okay, so if we talk about ipconfig, this is a command which is useful for displaying all the TCP network summary information which is currently available on a specific network that you are running this command on. Okay, so it also helps to modify the DHCP protocol and DNS settings. So if you talk about DHCP protocol, that is not part of this video, but I would say that DHCP, it stands for Dynamic Host Configuration Protocol, which automatically assigns IP addresses to the network devices. Okay, so if we talk about ifconfig, this command basically, this stands for interface configuration, and it is a command that is used in Linux and Mac as well, and the other Unix operating systems if you talk about. So it is used to control the TCP IP network interface parameters from CLI, and CLI stands for command line interface, and it allows you to see the IP addresses of these network interfaces. In fact, I can show you right now. I'm on a Linux operating system. So what I can do, that I can just simply type in here ifconfig, and you can see that I have the results. All right. So here you can see that I have different network interfaces that I can actually take a look at. Okay, so right here and here as well. So yeah, that was it for this question. So now let's move on to the next question, which is question number 7, and which is, what is a link? So if you talk about a link, it refers to the connectivity between two devices, obviously, link, So it includes the type of cables and protocols used in order for one device to be able to communicate with the other. So it could be wireless connectivity as well. You can call that a link as well. So yeah, that's pretty much it for link. So now let's move on to the next question, is what is the maximum length allowed for a UDP cable? So the idea is that a single segment of UDP cable, it has an allowable length of I think 90 to 100 meters. Okay, so this limitation, it can be overcome by using repeaters and switches. If you want to basically increase the length, the maximum length, the limit for a UDP cable, you can do so by using repeaters and switches, as I have said. So that was a basic question as well. So now let's move on to the next one. So now perhaps this is the most important question of this entire video, and this question could be asked everywhere you go. So there, I think, someone is going to ask you at least one question from this. So this is like, you can say there could be multiple questions from this one question. Okay, so the question says, what are the layers in OSI reference model? And obviously Could you describe each layer briefly? So the idea is that there are basically 7 layers of OSI reference model, and I'll explain to you each layer separately. All right. So number 1, let me just shorten the size of the text so that you can be comfortable looking. So the layer number 1 is physical layer. Okay. So if you talk about physical layer, it is the layer that converts data bits into electrical impulses, or you can say radio signals. All right. So the example of physical layer would be Ethernet. Okay. So the second layer, that would be data link layer. Okay. So it is a second layer, and it is like you can say it is a level 2. And at the data link layer, data packets are encoded and decoded into bits, and it provides a node to node data transfer. Okay. So data link layer also detects the errors that has been occurred in the physical layer. All right. So the next layer, or the third layer, is basically the network layer. Okay. So the network layer, it is also called as layer number 3, and it transfers variable length data sequence from one node to another node in the same network. So this variable length data sequence is also known as datagrams as well. Okay. So then we have the fourth layer, which is known as, let me just write here, transport layer. Okay. Transport layer. So if you talk about transport layer, it transfers data between nodes and also provides acknowledgement of successful data transmission. If the data has not been transmitted successfully, it would not acknowledge it. Okay. So it keeps track of transmission and sends the segment again if the transmission has been failed. And the fifth one is the session layer. Okay, that is very important layer as well. So the session layer, if we talk about, this is the fifth layer, and it manages and controls the connections between computers. This layer establishes, coordinates, exchange, and terminates the connections between local and remote applications. So the sixth layer, the second last layer, is the presentation layer. Let me just write it down here quickly. Presentation layer, and this is also called as the layer number 6. And you can also say it is a syntax layer as well. Okay, it is just its second name, and this layer transforms the data into the form in which the application layer accepts. Okay, so this layer transforms the data into the form, whatever form that application layer is going to accepts, and the application layer, for your information, is the layer number 7. So if we write here application layer, just application layer, this is the last but not least, it is the application layer, which is layer number 7. This is the last layer of OSI reference model and is the one which is close to the end user. Okay, so both the end user and the application layer interacts with the software application, and this layer provides services for email, file transfer, and messaging, etc. Okay, so that was it for OSI model, and I've explained to you each layer shortly and briefly. So if you want further explanation of each layer, you can just go to Google, and you would find tons and tons and tons of information about these layers, but I have summarized each layer very effectively. And if you just remember that was the main concept that I have told you. If you just remember that, trust me, it's gonna look like that you know everything about layers, but I would recommend you that you read each layer separately in detail so that you get a better idea. Okay, so now let's move on to the question number 10, which is explain TCP IP model. So the idea is that it is the most widely used and available protocol, and TCP stands for Transmission Control Protocol and Internet Protocol. So TCP/IP, it specifies how data should be packaged, transmitted, and routed in their end-to-end data communications. Okay, so if you compare TCP with OSI had 7 layers, while TCP, it has like 4 layers. Okay, so in those 4 layers you have application layer, transport layer, network or internet layer, and the network interface layer. Okay, so let me explain to you each of that. So what I'm going to do that I'm just going to decrease the size of it, and I'm just going to write here, let me just write it here. Okay, so there are 4 layers, and the number 1 layer is basically the application layer. Okay, so if you talk about the application layer, then this is the top layer in the TCP/IP model, and it includes processes that use transport layer protocol to transmit the data to their destination. Okay, so there are different application layer protocols which it uses, such as HTTP, FTP, SMTP, SNMP protocols, etc. So the first layer is the application layer. This is the top layer in the TCP/IP model, and this is the layer which includes processes that use transport layer protocol to transmit the data to their destination. And there are different application layer protocols, and one of them is HTTP, and there are others such as FTP, SMTP protocols, etc. So the second layer in TCP/IP model is transport layer. Okay, so let me just write here transport layer. So the transport layer, it receives the data from the application layer, which is above the transport layer. It acts as a backbone between the host system connected with each other, and it mainly concerns about the transmission of data. So TCP and UDP are mainly used as transport layer protocols. Okay, so if you talk about the third layer in TCP/IP model, that is the internet layer. Okay, or you can also say network layer. So this layer sends the packets across the network. Packets mainly contain source and destination IP addresses and actual data which has to be, or which needs to be transmitted. Okay, so the last layer in TCP/IP model, it is the network interface layer, or NIL. Okay, so network interface layer, it is the lowest layer of the TCP/IP model, and it transfers the packets between different hosts. It includes encapsulation of IP packets into frames, mapping IP addresses to physical hardware devices, etc. So these were the 4 layers of TCP/IP model, and I have explained to you in detail. I have summarized 4 layers for you. So now you know the difference and between OSI model and TCP/IP model as well. So TCP/IP model, it has 4 layers, and the OSI model, it has 7 layers, and I have summarized all these layers for you, okay, of both of these models. So now let's move on to the next question, which is question number 11. This is the last question, last but not least. What are the differences between hub, switch, and router? If you talk about hub, then let me just write it down here. So we'll make a list, hub, and then we'll write here switch, and then we'll write here router. Okay, so the main differences, if you say, then the difference number 1 is that hub is like, it's on physical layer. Okay, it's a physical layer device. And if you talk about switch, it is the data link layer device, and router is for network layer. Okay, so you can just write it down here that hub is a physical layer device, okay, PLD, and switch is a data link device, okay, DLD, and router is a network layer device, okay, NLD. So these, this is the main difference. And if you talk about hub, let me just mark it. So if you talk about hub, it simply repeats the signal to all ports. And if you talk about switch, it doesn't simply repeat but filters the content by MAC or LAN address. Okay. And if you talk about router, it basically routes the data based on these IP addresses that we have talked about. Okay. And the next difference would be that if you talk about hub, it connects devices within a single LAN. Okay. And if you talk about switch, just remember what I'm talking about. Okay, you can write that down as well. Okay, I'm not writing intentionally here because I want you to write on a pen and paper. Okay, so that you can get a better understanding. Okay, so if you talk about switch, it connects multiple sublans within a single LAN. Okay, so as far as hub was concerned, it used to connect devices within a single line, and switches, they basically can connect multiple sublans within a single line. And if you talk about routers, they basically, let me just mark that. So if you talk about routers, they can connect multiple LANs and WANs together. Okay, so yeah, I think that these were the differences that are enough. So if you just memorize these differences, I think it's not very hard to memorize, because once you understand it, it would be easy to memorize it. In fact, don't memorize it. You just have to know these basic simple differences. Okay, so I hope you have got the point. You have learned something new from today's video. I hope you have enjoyed it. If you have any questions, ask them in the comments below. For written articles, you can always visit our website linuxhin.com. Thank you so much for watching.